So we are going to look into systems of linear equations in two variables. We call them linear equations because both equations in a system would be a line. So what does the solution mean? The solution is simply the point of intersection of the two lines. So if we have two parallel lines, then parallel lines do not intersect and we will have no solution. But if we have two proper lines, such as the second graph there, they would intersect at one point and we'd have exactly one solution. But if both lines are the same, or both equations refer to the same line, then those two lines would intersect at infinitely many points, as shown in the third image. So if we either have one solution or infinite solutions, we call the system to be consistent. If it has no solution, then the system is inconsistent. So there are two approaches to solve a system of equations. So here we have two equations. I'm going to rewrite the second one to show that we are dealing with a line. 2x plus y equals 1, which would imply y is equal to 1 minus 2x. And if I rewrote that, I would have negative 2x plus 1. So negative 2 would be the slope and 1 would be the intercept. So you can rewrite the other equation in using the same process, and you'd find that we're dealing with another line. So what does the substitution method say? So first off, we rewrite the equation like I just did. It doesn't matter which one you pick, but you pick the one that is going to be easy to work with. So I'm going to pick the second equation. So I have an expression for y. I'm going to take that and substitute for y in the other equation. So I have minus 2x plus 1 equals 4. So 3x minus 4x plus 2 would equal 4, which would imply negative x plus 2 equals 4. Negative x would equal 4 minus 2, which would mean negative x is 2, therefore x is negative 2. Once we find the value of x, we take that and plug it in the expression that we started with. So y would equal negative 2 times negative 2 plus 1. Y would be equal to 4 plus 1, which is y equals 5. So as a point or a coordinate, this would be negative 2, 5, and negative 2, 5 is the point of intersection of the two lines. So we are going to solve the next system via substitution. So I'm going to pick the easy one. The easy one would be the first one. So I'm going to take x is equal to 3y and plug that expression in the other equation for x. So we have 5 times 3y plus 2y equals 0. 15y plus 2y equals 0. 17y would equal 0, which would imply y equals 0 over 17, and that is simply 0. So we take this solution and plug it in the expression that we started with. So x would simply be equal to 3 times 0. We get 0. The second method is called the addition method, and it involves two steps. The first step is elimination. The second step is substitution. So we move all terms, the variable terms, to one side. So I'm going to rewrite the first expression as 2x minus 3y equals 9. I'm going to rewrite the second expression by moving negative 3x. So I have 3x plus 4y equals 8. So of the two variables, I've got to pick one to eliminate. So first step, elimination. And I find x to be the easier variable to eliminate. So I want to come up with a common factor between 2 and 3. That is going to be 6. So I am going to multiply the first equation by 3 on both sides. 3 times 2 would be 6. Negative 3 times 3 would be negative 9. 9 times 3 would be 27. I'm going to multiply the second equation by 2 on both sides. 6x plus 8y would equal 16. And I am going to subtract the 2. The 6x would go away. 9y, negative 9y, minus 8y is negative 17y. 27 minus 16 is 11. I am going to divide by negative 17 on both sides. So I have negative 17 over negative 17 equals 11 over negative 17. So the solution to y is negative 11 over 17. The second step is back substitution. So I'm going to take the value of y that I've found. I'm going to plug it in one of the two equations. You can pick the equation that you feel most comfortable with. I'm going to go with the first one. 2x minus 3 times negative 11 over 17 would equal 9. 2x plus 33 over 17 would equal 9. 2x would equal 9 minus 33 over 17. And if I have to combine the two numbers, I need to find a common denominator, which would be 17. Solution. So we want to solve the next system by addition method, and we have a perfectly good system in the sense the variables are on one side, numbers on the other. And I am going to eliminate x. So I need to come up with a common factor between 2 and 3, which in this case would be 6. If I multiply by 2 on both sides, I have 2 times 3x minus 4y equals 2 times 11, which would imply 6x minus 8y equals 22. If I multiply by 3 on both sides with the second equation, I would have 6x plus 9y equals negative 12. I am going to subtract the 2. 6x minus 6x would go away. Negative 8y minus 9y is negative 17y. 22 minus 12 would be 22 plus 12. So I get 34. Y would be 34 over negative 17, which is negative 2. So the solution to y is negative 2. The next step is back substitution. I'm going to take this value of y and plug it in one of the two equations. I'm going to pick the first equation, 3x, minus 4 times negative 2 would equal 11, which would imply 3x plus 8 equals 11. 3x would be equal to 11 minus 8. Therefore, 3x is 3, or equal to 3. Divide by 3 on both sides, x would be equal to 1. If you recall, I mentioned in the previous example that if the denominator is the same, then you probably have the correct solution. Now, there are other ways to check if your solution is correct. All we have to do is take the value of x and y, plug it in both equations to see if the left-hand side matches the right-hand side. But do we have the same denominator in both x and y? Of course we do. The denominator in the solution to y is 1. The denominator in the solution to x is 1. So our solution is likely to be correct. So I'm going to pick the addition method for this one. So I want to eliminate the x term. So I'm going to multiply it by 2, first equation by 2. So 10x minus 4y equals 8. Negative 10x plus 4y equals 7. And we have to add these two. I end up getting 10x minus 10x. Negative 4y and 4y would go away. That would give me 0. 8 plus 7 is 15. So I end up getting 0 to equal to 15. Now, that just cannot happen. It is not a proper statement because 0 cannot equal to 15. This could only mean that this system has no solution. The consequence being that the two lines are parallel to each other. And that would imply that there is no point of intersection. Parallel lines do not intersect. And the system is inconsistent. Example 6, I'm going to use substitution method because that seems easy to me because we already have x in terms of y. So I'm going to take that and plug it in the second equation. So I have 5 times 4y minus 8 minus 20y equals minus 40, which would imply 20y minus 40 minus 20y equals minus 40. So the 20y can go away, and minus 40 is equal to minus 40. Now this is a true statement. Negative 40 would always equal to 40. So this should immediately conclude that there are infinite solutions to the system. The two equations are the same. In other words, they correspond to the same line, which would imply that there are Example 7 is a word problem, and we want to translate the word problem to a system of equations. So here we have the sum of 3 times the first number and twice the second number is 8. I'm going to call the first number as x, the second number as y. So 3 times x plus 2 times y equals 8. And if the second number is subtracted from twice the first, so 2x minus y, the second number is subtracted from twice the value of x, the result is 3. And we want to find the numbers. I am going to eliminate y. So I'm going to multiply the second equation by 2 on both sides. So I have 4x minus 2y equals 6. And if I add those two, I would end up getting 3x plus 4x equals 7x. 8 plus 6 is 14. X is 14 over 7. So x is 2. So the first number is 2. I'm going to take this value of x and plug it in one of the two equations. I'm going to pick the second one. If you choose, you can pick the first one. So 2 times 2 minus y equals 3. 4 minus y would equal 3. Negative y would equal 3 minus 4. Negative y would equal negative 1, which would imply y equals 1. So the two numbers are x is equal to 2 and y equals 1. Here is another word problem, and it has to deal with cost function, revenue, and profit. So we know that the cost function is the fixed cost of a product plus the cost per unit multiplied by the number of units of the product. The revenue is simply the price per unit multiplied by the number of units we sell, and profit is simply revenue minus cost. And if the profit is 0, then we simply broke even. In other words, whatever revenue we generated equals the cost, so, we broke even. So here is an example. A company manufactures shoes and it has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair, and shoes are sold at $80 per pair. So I'm going to translate the first equation to get the cost function. X is the number of pairs of shoes, so the fixed cost is $300,000, and it takes $30 to produce a pair, so I'm going to multiply 30 by x. So that would be our cost function. The revenue is simply the price per unit multiplied by the number of units. So the price per unit is 80, and we're going to multiply it by the number of units that we sell, so that would be x. The profit is simply revenue minus cost, so we have 80x minus 300,000 plus 30x, so 80x minus 300,000 minus 30x, which would imply 50x minus 300,000. And how do we find the break-even point? If the profit is 0, then we have the break-even point. So set P of x equal to 0, and we solve for x. So 50x minus 300,000 would equal 0, 50x would equal 300,000, x would equal 300,000 divided by 50, and that would equal 6,000. So we have to sell 6,000 pairs to break even. And if we are able to sell more than 6,000 pairs, that would imply profit. And if we sell less than 6,000 pairs, we would incur loss.